right here, and his back is forward and forward is back. There we go, right? All right. Let me know when you want me to shoot away. All right. Bonnier. All right, ladies and gentlemen, we're going to get started. Normally, I tell everyone that we've got 68 slides in an hour and a half to talk about coil cleaning. But that's not true. We've got 14 slides, hopefully some good stories, and we got candy. And believe it or not, I am, as Josh can attest, I am not above maybe hitting a very well-dressed female director of a large hospital in the head with a piece of candy. She did not grow up a softball player, I can tell you that, but she was in the back going like this. She really wanted candy to answer a question, and I, right in the forehead, you know, so I'm not above that, so just be warned, okay? Purpose of this whole presentation is to, you know, called optimize, and I'm in my little zone here, so I'm getting used to it, just to make your systems better. And my little piece is coil cleaning, but really we want at the end of the day your systems to be more efficient, operate better, less hot calls, all that stuff. So, you know, that's kind of our goal. We're going to do that with this little presentation. My background is I'm Brad Johnson. I was a water treatment guy back in the 90s. If you'll Nalco Bob, I knew Nalco Bob back 100 years ago. So my background is not, you don't want me changing any compressors or valves or any of this stuff because I am a water chemistry guy by nature. I started off with Nalco, and then I was at U.S. Water Services, you know, Department of Defense, big systems. You know, the boilers were 100,000 PSI minimum. But I'd left and came back after some family drama that I had to kind of clear up, and I was doing actually filter testing for Nalco. And so I was doing these, they're trying to build a case to compete against Jed and Josh for filters. And I was doing all these studies, and the bottom line is they didn't compete with Jed and Josh and filters. And they were also trying to sell some cheap filters that you know, for 55 bucks, you get in the Grainger catalog for 26 bucks, and it was garbage. But, but to do all this testing, I had to have a clean coil. And so I started off up here at Colorado State University, and then across the street from Hewlett-Packard at a site to be unnamed, Intel. It was an old Celestica site, and I was doing this fancy testing, you know, with data loggers and all this stuff. And I couldn't do the testing because none of the coils were clean. You know, the Intel site was just an old Celestica site. They didn't change any of the equipment. Did a lot of work at UW early on. We'll talk about that in a minute. So I had to figure out how to clean these coils so I could do this filter testing. So that's what I did. You know, I figured Tyson Food research and all this stuff. So, you know, the anatomy zoology building at CSU was in hand, 60 hertz. They couldn't pressurize the building, and the filters were brand new. So I cleaned it, and then all of a sudden we're blowing feathers out the backside, 1,200 feet per minute, just because we cleaned the coil. So that's kind of how I started this business. But I was at Nalco, so I had to go over to U.S. Water, help a buddy out there for a while because I didn't want to violate a non-compete, which we all know. And once I kind of had my little side hustle going up in the mountains, Vail Valley Hospital, Mesa State University, my only non-former Nalco customer was that big IBM site just north of Boulder, kind of south, you know, 22,000 tons just in one of the cooling plants. You guys know where it is. And I got called into a room, and they said, guys, IBM executives get paid a lot of money to save energy, and we get a rebate. It was Fluor at the time. We get a big rebate on our contract if you save us kilowatts. So on the weekends, I was cleaning coils at these, you know, 30 buildings out there, and they're doing all these energy studies, and they figured out that these IBM executives can get paid a lot of money, and Fluor can get a big rebate. So I kind of got in business earlier than I wanted, not for the right reasons, but here I am today. That was 2011. So optimize. What does it mean? Let me see. Make the best of or most efficient use of. Okay, how do we do that when it comes to coil cleaning? Well, we find systems every single day. You got great control systems, you got great filters, but they're just a disaster. Just like this in the corner. These are on the evap side. Almost always we find these. We can't even go 1 or 2 jobs without finding these. And then you find that you have a big, huge air wall, and then You walk in there and the filter on the bottom right side that you can't see through the portals pulled. No airflow, right? People are busy. And then UW? Are you Wyoming? Okay, Cheyenne, okay. When I first started this company, I didn't know anything about HVAC. University of Wyoming, Steve Fletcher, God bless him, was one of our first customers. We cleaned the Earth Science building. Promptly shut down the whole thing. So they had red clay coming out, just oozing out of this. It's a pretty new building. Cleaned this big evap coil, and of course I'm like, what on earth did I just do, right? Turns out that they never thought the coil was plugged. They're just going around robbing Peter to pay Paul from all the different dampeners. They're changing the static duct pressure, and we reduced the pressure so much that we're outside their set points. It happens all the time, but believe me, that was a moment for me when I was young. It's like, oh boy, here we go. And then another thing, when I was a chemical guy, and you guys can attest, and ladies can attest to this, when I was downtown, I would go into a 1 million square foot building, chief, assistant chief, 6 or 7 full-blown techs that could break down motors, change belts, 3 apprentices, and a light bulb changer. 1 human being for every 100,000 square foot. This is a commercial building, not a hospital, not a data center. It was 1 human for every 100,000 square feet. How many people think that happens today? Assistant, good for you. But bottom line is everyone's shorthanded. A lot of stuff just doesn't get done. All right. Now for the candy part. Why do we clean coils? Anyone? Who said that? I got my game on. Anyone else? Come on. Someone's got to. Who said that? Jeez, oh wait. There you go. All right, bad shot. All right, keep going. Anyone else? All right. Energy savings. Who said that? There you go. All right, there you go. All right. Josh, having a little issue here, bud. All right. Where's Josh? All right, well, let's see if I can change the slide the old-fashioned way, the arrow. If I can find the arrow. Hang on here. Hang on. Well, this is awkward. Let's see if there's an arrow on here. There you go. See if I can. All right. If someone get Josh, that'd be great. But we don't need the slides. I'm used to giving speeches in bars. All right. All right. But you're right. Energy savings, airflow, really, from your perspective, less hot calls. That's why we do it. Let me see what we got going on here. All right, help me out.
Just quit working out of nowhere?
All right.
It works? What are you talking about?
Yeah. All right, here we go. I am on.
You have to press the right button.
All right. Coil cleaning saves time, energy, money, resources, labor, emissions, operating costs, capital costs, hot calls, after-hours calls, and headaches. All right, moving forward. We're going to get to this in a little bit, but one time I was at a Lockheed Martin Space Systems, and I was supposed to meet one guy, and I walked into a conference room, and there's 14 guys there, and there's only 2 facilities guys. Everyone else is rocket scientists. I was like, oh, you got to be kidding me. And they want to talk about enthalpy. I'm an engineer, but I'm not a rocket scientist. I don't want to talk about enthalpy. And they want to talk about why they should clean coils. And the smartest guy in the room with initials after his name and said, gentlemen, I'm going to go back and design rockets. Dirty is bad, clean is good. And he got up and walked out. Department of energy savings from regular coil cleanings, researchers predict 20 to 30% efficiency improvement and 20% energy savings. That's the Department of Energy. All right. So we're going to get the reduced hot calls. All right. Another University of Wyoming story here. We cleaned the whole campus of UW. And this big old cowboy comes up to me and says, "Are you Brad?" And I said, "Yes, I am. Don't kill me." He's a big old boy. And he said, "You reduced our hot calls 47%. You know, Justin, that's this big old burly dude. And this is in the early days." I'm like, "Don't kill me. He's a big guy." But it was just the fact that it had never been done before. You know, people just always forget the EVAPs. They don't have enough people. They don't have the right equipment. So, all right. We're on the right spot. All right. Why does cleaning a coil reduce hot calls? Candy? Oh, there you go. Didn't get you in the head. Good. What? Yep. Anyone else? Come on. Anyone hungry? There you go. All right. Well, here's why. Cleaning coils restores efficiency. And this is a pretty good slide. And here's the crazy part, right? It restores your capacity. When they do these studies, it's light, medium, and you know, heavy soiling. But the heavy soiling has nothing to do with the right. You know, we don't see anything that's light, medium, or heavy. We see disasters. And this coil on the left kind of tells a story that pre-clean, that coil on the left, that's the main terminal at DIA. This is when I first started this company. We're out and about, and I said, "Well, guys, you want to clean coils, you pick a nasty, disgusting coil, we make it clean, and then you go get us money, and we go clean coils." He said, "No, you watch. Delta T across that thing was 4 degrees. And when they designed DIA, the air intakes are right where you drop off all the passengers trapped underneath the parking garage. So they suck in 250,000 cars worth of exhaust every day. So we start cleaning this coil, you know, doing our thing. You got the chemicals reacting, and all of a sudden you get this black ooze that's coming out from all the auto exhaust. The coil looked brand new, but we got it to 16. We didn't get it to 20, but they tried working on it for 3 days, and they only got 2 degrees. It's just, you got to do it correctly. So anyway, that's that there. All right, we are on. Okay, now this is another funny story that's kind of crazy. Look at that coil. Who thinks those are medium to mild dirty? Sure, yeah, those are pretty hairy. And we never name names. This is a Southern Colorado hospital feeding 7 operating rooms. You know, it'd be good for Jed or Josh because they could sell a whole bunch of HEPA filters, right? This is, you open this up and you just kind of pull the director aside. So here's your photos. He said, "Good. Don't send them anywhere else. We're good." You know, but that's what we find all the time. You know. All right. Well, let me see this one here. Okay. Let me do this right here. Hot call saves energy. We saw that about the Department of Energy study before. It restores capacity. How does it save energy? Right here, see this roof right here? This is a large data center, condensers on the roof of a data center, right? And believe it or not, data centers are weird and they're desperate and all this stuff. That roof looks pretty full. Would everyone kind of agree with that? There's 89 condensers, and on the perimeter, there's 40 RTUs on that roof right there. Today, there's 128 condensers on that exact same roof, and they're bigger. It's crazy. You walk in, but when this is now, it used to be Verizon, now it's called Equinix. They have all their weird names, you know. And when we first cleaned that, we cleaned 90 units. We did it for 3 years, and then the guy pulled me aside and said, "We always ran every single unit 100% of the time. We never cleaned them. Half these units haven't run since you've cleaned them because they're lead and lag." All it was just you get guys up there for 2.5 weeks and you just clean the condensers. You know, how many guys think they have at an average data center? Not enough to walk around and clean condensers. So that's how you save energy right there, is you just restore capacity, and half of them don't even work after run. This is Intel. Don't sue me, but this is 2 weeks. And this is back when kilowatts were 6 cents an hour. I don't know, what is kilowatt? What is cost for a kilowatt hour now? 12? Okay, so that tells a story. All I did is I put a data logger with a VFD on a fan motor for 2 weeks. I cleaned the coil and I ran it for 2 more weeks. $4,400 worth of savings. This is when I first got started. I mean, since then all the energy studies came off, but this is what I did, and that was the old Celestica Intel. It's right across from HP. It's their R&D site. Let's see, what slide is that? So I get to my spot here. All right. Who thinks that coil cleaning automatically saves energy? All right. Oh. How about you? Anyone? All right, anyone? All right, actually, it is a trick question. You guys are right not to raise your hand. Cleaning coils restores efficiency. When I told you about that story where we changed the delta T at the airport, we actually dropped the temperature of the main terminal 11 degrees at DIA. But if you're trying to get to 72 and you can only get to 82 and all of a sudden you get to 72, that's physics. That's more work. That's more energy. If you put that back to 82, you'd save tons of energy. But you've now given yourself a choice. You can find some halfway point. You've done the work more efficiently, but if your motors spin faster and you send more BTUs back to your chiller, you're going to spend more energy. You're just going to do the same amount of work much, much more efficiently. You get it. All right, here you go. This guy's raising his hand right here. There you go. Ooh, all right. All right. Let's see here. Now, where are we at here? Now, this is the ultimate savings opportunity. And and you guys laugh. We find this all the time. We have a marketing piece that is that bad or worse, but it looks like biological and slimy. And we're at a large industrial complex, and this guy is an engineer, and he's all proud, and he's a really smart guy, and he's like, "That's the worst coil I've ever seen." And my sales guy starts dying. He's like, "That's your facility." And he's like, "Oh," and it was funny. So at least the guy has a sense of humor, and it was kind of by the IBM site. But this right here is DIA, all right, and this is a true and funny story. We are trying to find this. This is down in the bowels where they say that underneath you go 2 levels down and you're on a cart and you go back where the old baggage system used to be. All kinds of equipment, and we found a full-blown apartment back there with a guy sleeping on a couch. Cable TV, refrigerator, couch, refrigerator, cable TV, which was huge, right? You're going coring through the chase to get there. And we found out later that it was 3 United guys that would check in and only 2 would go to work. It wasn't our job to tattle, but these guys had a pretty good racket going, and you'd never find this. So we got back, we found this coil. It wasn't where we thought it was, but and we took a feather in front of this coil. This is a fixed speed, like a 50-horse motor that had all these multiple coil sections. And the offices had been vacant for like 7 years, and you could take a piece of feather on the back side of that coil, and it would fall straight to the ground. So I talked to the director and said, "You know how to save a bunch of energy, don't you?" And he said, "How's that?" Turned it off. You're not getting any energy at all. And she said, "Well, that's not my department." I'm like, "Well, whatever." But that's probably $30,000 a year of just electrical on this massive motor that's just sitting there. So there's an energy saving story for you. So coil cleaning saves energy. All right. So reduces hot calls, saves energy. And has anyone here heard of the Jeffco story that I often tell? Okay. We're a small company. My attorney is the one I give a credit card to. I don't have a law firm, we're a small business. We clean Jefferson County School District, which has got, that time, had 291 schools. So it's big. And they've got a Taj Mahal right across from the Federal Center on I-70, right? And there's a pit, and there's 3 chillers and a bunch of equipment, and we're cleaning it. And all of a sudden, 6 people are watching us clean coils. It's not an exciting activity. It really isn't. But there's water that goes down, there's a drain, and there's a retention pond, and we're vacuuming it up and sending it to a trailer. Like 4 months later, I'm with a very, very, very large mechanical company that has probably 100 trucks or more. And he said, well, we cleaned that one last. I was in handcuffs. What happened? Because like I said, my attorney is the one I give a credit card to. These are guys, we're just letting it go to that retention pond. And everyone's got a camera. Angry, pissed off teacher, administrator called the EPA, which is right up the street at the Federal Center. And there's Jefferson County deputies, federal marshals, and they're in the back talking about coil cleaning. Obviously, we did something right. But my point is, whether we do it or you do it, someone's always got a camera. So do it right. Don't follow the rules as far as where that stuff goes, because there's always someone that hates their life, and they're going to take it out on you. Whether it's right or wrong, it was really no big deal because they were just even using water. They weren't even using chemical. They weren't cleaning them very well, but they weren't really doing anything that I would consider abhorrent for the environment. But they were still calling, this company's big enough, they have their own attorney. So you want to stay green and you want to do it right, and everyone has a cell phone. Just word of warning, because I wouldn't want to be in those situations. So here, now I'm going to tell you how to clean coils and how not to clean coils. First thing is we use what we call kind of a sissy pressure washer. Someone told me that was a little bit insensitive, but kind of where we're at. But basically what you want is we use anywhere, depends on the situation, from 400 to 1500 PSI. But it doesn't throw a lot of water. Okay, because it's kind of, I used to get custom pumps. Now I just find the right pumps, as opposed to a garden hose. If you clean it with a garden hose and you put the good stuff, the new bright on it, all you're doing is you're taking the gradu and you're shoving it into your coil, and the chemical is shining the front side of that coil, and you're making yourself feel good about what you're doing, but you're making it worse. So we use kind of the sissy pressure washer method. We use a chemical process. If you do clean your coils, use chemical because it matters, because the water is really just the float. It gets harder with condensers because obviously with these microchannel condensers, you're kind of stuck with water. But if you clean an evap coil or an older style, coil, if you can use chemical, do it, because the water will tend to improve your airflow because you're just kind of blowing all the gradu out of there. But you're really trying to get the chemical to break up that smog. Carbon, that's an insulator. That's what kind of reduces your heat transfer on your coils. All right. So we recommend a chemical process. Don't use a pressure washer. We did a school district down in the Springs. We love this guy. Was an old guy. He knew what he was doing, but he was old. His knees were broken. And he said, I'm going to have you clean the coil. We've replaced 13 compressors at $23,000 a piece. And you go up there, and it's an elementary school, and the unit is up high, so you're not going to get on top. But we go up there, and he knew, and he felt bad, and he didn't know. Some young buck, not us, had taken a 4,000 PSA pressure washer and just took all the fins and just went. Coils were totally clean. And I said, dude, you need a new coil. You don't really need us to clean your coil. There's nothing to clean. You're popping compressors because you've just got zero airflow. You've just, some young intern just completely just, so don't use a pressure washer on your coils unless it's kind of a sissy pressure washer. But he'd been through like compressor after compressor after compressor. But he was an older guy. He would have known that, but he's not climbing up where this thing was. This is a young person's game, right? Every 3 to 4 years on your EVAPs, that's kind of moved to every other year. It's kind of political, kind of COVID-ish, Green Energized Denver. I believe that every 3.1 years you should clean your EVAPs, and that's when it pays you to pay me. That's kind of what I think, but people kind of do it every other year. Some people do it every year just to keep it in the budget, but it's not something you don't have to clean an EVAP annually. What we did with the airport is we started with the main terminal. After we cleaned the whole thing, A the next year, B, C, and then back to the main terminal. At least you're getting them clean. You don't need to have quarterly cleanings. Some people do that. Some of these super squared away Navy guys, any of you go in your boiler room, looks like you can eat off it. You still don't need to clean your coils every quarter. Steam, we don't use it because it's hard to manage, but there is some validity to using steam. Don't pour the blue stuff on your coil. We see it all the time. Mechanical contractor's busy. They get an emergency call. You know, they know better, but they're 4 calls down. They just take the new bright and they just bloop, 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 bloop. It does a good job, but you're going to melt that roof. Eventually, the attorneys are, you know, the stuff works. It's great, but eventually, you're going to melt the roof with neat product. It's supposed to be like 7 to 1. Don't just dump it on top of it. It will work, but everyone's got a cell phone, right? You know, the flood method. If you have a plugged, this is more for any data center guys, kind of a horizontal condenser that are plugged. You can hammer away, but sometimes you can just turn into a big bathtub, and that does work. You know, and I would not use chemical doing that, because as long as it doesn't go to the storm drain, you're fine. You're supposed to evaporate, but you could just fill that thing up, and then eventually gravity takes over and kind of finds a way. That is a pretty good method to clean a condenser. Don't use the sprinkler method. I've been in a very uncomfortable meeting at Comcast as the third party. Whether it's a mister, and I hope no one sells the mister, they do work. The physics is sound until they don't. So some people, you have a condenser, you can't hit your temperatures. You're at a data center, huge pressure. You go to Home Depot, buy a sprinkler. The physics is there. It will work. The misters do work. They work very well until that RO cartridge goes bad. And then they switch the water source in Colorado. They go from a clean water source to another water source that's loaded with calcium. I have literally been in a meeting where I charge triple, and I'm pouring hydrochloric acid over condensers because they're going to shut down a $100 million data center. And I would not want to be the person or that has those attorneys coming after you for that. So just don't do it. You probably get away with it for a while, but when you don't, you're gonna replace the coil. I mean, even with that, pouring straight like they used to do in the old days with radiators, pouring straight pool acid on, you know, you're destroying copper, you're destroying the roof. But we're doing that, and we have a waiver, of course. We still only got like 40% of the capacity back dumping pool acid. So don't do a sprinkler. You can clean a condenser almost anytime it's dirty. Most people wait till after cottonwood season, just because why do it twice? But yeah, if a condenser is dirty, you can clean that anytime, because that's directly helping the compressor and the energy savings. Anything else? Any questions? Bless you. Need some Snickers? Anyone need candy? There you go. Which one do you want? Oh, there you go. Oh. Who said they want a Twix? Oh, there you go. All right. That guy played baseball. All right, guys. Thank you very much. I appreciate it. All right.